Hi there, welcome to your lesson on measures of dispersion. Here we have two data sets graphed on here, data set A and data set B. Notice data set A has this curve here that represents it, and data set B has this one. So which of these shows more spread? Well, clearly data set B is more spread out, and that's what measures of dispersion is all about. The spread of data, and we can see that here in data set B. It's very spread out. It goes from 2 to 40, whereas data set A only goes from 10 to 31. So, welcome to measures of dispersion. Let's get going on this here. In the last lesson, we looked at measures of central tendency. These told us all about the center of a data set, and they were mode, median, and mean. Now we are looking at measures of dispersion. They tell us about the spread of a data set. How spread out is the data from the mean, in other words? The common measures of dispersion are number one, range. It is the simplest measure of dispersion. Basically, to find the range, we just do highest value minus lowest value. Another measure of dispersion is called the interquartile range. It's also like a range, but it's between what are called the Q3 and the Q1 values. So we can write IQR, interquartile range, as Q3 minus Q1. We'll look at this very soon. And another common measure of dispersion is called standard deviation. We will look at this powerful measure of dispersion in the next lesson. Okay, let's say we have this data set here. The range, like we said, is just max minus min. In this case, max value 95 minus the minimum 1, and we say the range of this data set is 94. Okay, we can also take this data set and kind of divide it into pieces. So I've taken the data and I've divided into the bottom 25%, the next 25%, the next one, and the upper 25%. So Q1, that's called quartile 1, but we'll get to that in a second. Let's start with the Q2, which is the median. The median is known also as Q2, okay? So we know to find the median, we can find the position of the median by doing number of data points plus 1 divided by 2. Now let's look at median in a different way. We know the median value is the value in the middle of the data set, right? So if we say I want to start at the beginning of the data set and get to the median value, we know we have to go 50% of the way through the data. So I'm showing you now another way to think of median. Instead of doing n plus 1 over 2, we can do 0.5 times n plus 1. And that's exactly what we see here too, because you can factor out a fraction from here, a half, and put a half in front of n plus 1, and that's what we have here. We are basically saying go 50% of the way into the data set and you get the median position. So 0.5 times n plus 1. In our case, we have 11 data points, so 11 plus 1 is 12. So 0.5 of 12, or we can say 12 divided by half, which is the same thing. 12 divided by 2, and we get 6. So at position number 6, we have the median, or Q2 value. We're going to call it quartile 2 now. 1, 2, 3, 4, 5, 6. Position number 6. That's your Q2 value. Okay, that's the median. Now, let's talk about quartile 1 and quartile 3. Quartile 1 is like the midpoint of the first half of the data. So if the median was 50% of the way through the data, quartile 1 is 25% of the way through the data. So now, to find Q1, we are just going to do 0.25 times n plus 1. We're saying we're going 25% of the way into the data set. So 0.25 times n plus 1. In this case, 0.25 times 12. And 1/4 of 12 is 3. So we know if we go 1, 2, 3, to the third data point in our data set, we are at the Q1 value, which is again the halfway point to the Q2 value. And that makes sense. 4 is now our Q1 value, and we can see 4 is exactly halfway on our way to the median. Okay, now look at Q3, quartile 3. It is now the 75% mark in the data set, right? It's the halfway point in the upper half of the data. So to get there, again, to get to Q3, we do 0.75 times all our data, because we are now talking about being 75% of the way through all our data. So 0.75 times n plus 1 is 0.75 times 12, which is 3/4 of 12, which is 9. And again, Data point number 9, 1, 2, 3, 4, 5, 6, 7, 8, 9. Data point number 9 is right here. That is our Q3 value. And again, it makes sense. We can see it is exactly the middle point of this upper half. Everything makes sense. So that's Q1, Q3, Q2, which is the median, and now the range also. Make sure you absorb all this carefully. Let's go to the next slide. So, oh yeah, sorry, one last thing here. So we said that one way of representing dispersion is range. Another way is the interquartile range, and that's the range between the Q3 and Q1 values. So instead of doing max minus min, we're going to do Q3 minus Q1. So in our case, Q3 is 52, minus Q1, which is 4, and that gives us 48. Sometimes interquartile range is a better way to show dispersion because most of our data is in the middle there, and this data at the top 25% and the data at the bottom 25 is often kind of like outlier data in a way. All right, so two ways to show dispersion. Let's keep going. So for this data set here, we have this data set. It's already ordered for you. Find the median, the lower quartile, which is Q1, the upper quartile, which is Q3, the interquartile range, and then the range. Let's see if you can find all of those in one go. Okay, check your work here. We can see the median here, Q1, Q3, and then interquartile range and the range. Check your numbers carefully. Let's look at some basic things. First of all, we know the mean is here because we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 data points. So we do 12 plus 1, 13, divided by 2 gives us 6.5. And that's what's going on here. 12 plus 1 divided by 2, 6.5. 6.5th position is where the median is. That means it's in between the 6th and 7th data points. It's right in the middle. And what's the middle value between 36 and 49? We can just add those two and divide by 2, and we'll find out the middle between those is exactly 42.5. Now to find Q1, you look at the bottom half, and you're like, 0.25 times 13 will tell us that the bottom Q1 value is right here. We can also just eyeball that. We're like, well, we have 6 data points there, so the middle value will fall between number 3 and number 4 right here. That's our Q1 value. That's our 25% of the way through the data value. So what falls between 9 and 16? Well, if you add those up and divide by 2, we find the average, and the average between those two is 12.5, so that's our Q1 value. How about Q3? Q3 we know will fall right here, right in the middle of this upper half. And what's the number between 81 and 100? Well, you just add those up and divide by 2, you get 90.5. Great, now you know Q1, you know Q3, you can subtract those to get the interquartile range. You can do max minus min to find the range. Awesome, great job. Important stuff for statistics. Let's keep going. Oh, by the way, you can visualize the data like this, right? Here's our first quarter, second quarter, third, fourth, right? Here's our first quarter, second quarter, third quarter, fourth quarter, and the quartiles are the division lines between those, the data divided into quarters. Okay, now box plots are a powerful way to show all these things we've been talking about, the median, the quartiles, the range. Box plots look like this. They have a minimum value, first quartile, median, third quartile, maximum. Here's what it looks like. First, we figure out what these 5 numbers are, and then we can draw a box plot. Box plot looks like this. You have a box in the middle, and then a whisker here and a whisker here. The box begins at Q1, ends at Q3, and it has the median drawn in it as well. And then the whiskers go out to the minimum value, and another whisker goes out to the maximum value. So this shows the range all the way beginning to end. And then the interquartile range is shown within the box because that's Q1 to Q3. You've probably done these before, so let's take a look at an example of that. But before that, as we know, Q1 represents the point at which we are 25% of the way through the data. So this represents 25% of the data. Here's the next 25%, here's the next 25%, and here's the last upper 25%. So that's what shows us how our data is spread out. Okay, let's go back to example we looked at with 32 students writing a test with these scores here that they earned. Here's the data split into the 4 quarters. So here we have our median, Q2, something between 5 and 6, which would be 5.5. Here we have our Q1, or quartile 1, right here between this 3 and 4 here, which will be 3.5. And here we have Q3, which would be the number right between 7 and 7, which is 7, right? Okay, so we have our Q1, Q3, and all that. Again, that's 25% of our data. There's the next 25% of our data, the next, and so on and so on. Let's make a box plot. The box plot would look like this. Here it is. Our low score, our minimum is here, 0. Our high score, 10, is here. So that's the whisker, that's the whisker. Now to make the box, we know our Q1 value here, 3.5, so we can see this at 3.5. We know our Q3 value, like I said, is 7, because it's between 7 and 7, 7. We know our median is 5.5. It's right here. Common mistake, putting this median line right in the middle of the box. It's not always in the middle. We can see that here. The median is here. There's our box. Okay, great. There's our median. There's our Q1. There's our Q3. And our max and min at either end. Again, this is 25% of the data. This would be 50% of the data. In the middle 50%, and then our upper 25 would be here. Okay, this question, try this out. This represents data about 2 films, film A, film B, and the ages of the people watching those films. For film A, what percent of people were below 34 years of age? That answer is 25. Film A, 34 is here, and we can see that's Q1, therefore this is all your bottom 25% of ages. Great, next, for film B, what percent were above 32? All right, 50%. Next, where's that? 32, film B, yeah, this is 32, and that means this is 50% of the data above. For film A, what percent were between 34 and 49? Nice, 50%. This is 34 here to 49, so that's your middle 50%. Next, film B, what percent were between 22 and 46? 75%. Hope you're getting the hang of this. And number 5, what in general can you say about the 2 films? Well, film A was more like a family film because it shows a wider range of ages, right? Maybe you can say more. All right, let's talk about outliers. Outliers are pieces of data in your data set that are much different than the rest of the data. Here we can see an outlier. Most of the data is here. This one is an outlier. Okay, in a set of numbers, a number that is much larger or much smaller than the rest is called an outlier. Here is another data set, a scatter plot, and we have an outlier out here, another one here, another one here. Okay, most of the data is along that trend line here. Okay, to find outliers, we use this formula. We find the IQR, we multiply by 1.5, and then we go above and below Q1 and Q3 using that value we find. Let's look at an example. So here we have a box plot, and here's a potential outlier. Here's what we do. We find the interquartile range, so between Q3 and Q1. So IQR, Q3 minus Q1, 90 minus 70 is 20. Our IQR is 20. Now we multiply the IQR by 1.5. 20 times 1.5 is 30. So now we know anything 30 beyond 30 above Q3 and beyond 30 below Q1 is going to be an outlier. So for example, Q1 minus 30, okay, Q1 was 70, minus 30 gives us a value of 40. So anything in there is considered fine, but anything beyond 40 in this direction is an outlier. So this is definitely an outlier. Now let's look at an upper end. Again, we're going to take that 30 we just calculated, and we're going to go 30 above Q3. Q3 was 90. 30 above that brings us to 120. So anything from 90 to 120 would be okay, but anything beyond would be an outlier. That's how we find outliers. Okay. So look at this data set, create a box plot for this data set, and determine whether 37 is an outlier using the technique we just looked at. Let's see how you did. Here's our box plot. Check your Q1 and Q3 values carefully as well as your median. Here's the box plot drawn with our Q1, median, Q3, min, max. Here's the calculation where we figured out IQR and then 1.5 times IQR to check where the outliers are. If we do Q1 minus that 1.5 times IQR, we get this value. So anything below that would be an outlier. 37 is not below that, so it's not an outlier. Great. One last thing. How do we know when to keep or reject outliers? Well, Here's a case for removing an outlier, and here's one for keeping one. For example, we have these heights of boys. You can see 382 is in there. Whoa, that's clearly not measured correctly. There's no way somebody's that tall. Remove that outlier. Here, we have test scores. Bunch of students struggled, one did really well. Don't keep that outlier. It's important in this data set.